it gives us a system, and there's needing to be solved here. An easy way to do this is to substitute in these numbers like x, y, and z for each of these equations. So instead of 5x, you would say 5 times negative 12 minus 1 plus 3 times negative 5. And we're trying to see if that equals this negative 2 when we add all that up. After you substitute and you add it all up, you find out that this a, in fact, does not work for you. These aren't true equations when you're done. The faster way to do this, I think, is actually going to be on your calculator, and we can put a reduced row echelon form matrix into the calculator. To be able to do that, the first thing we have to have here is all of our columns in one complete set. So x's go here, y's go here, and z's go here. Remember, if you don't have any z's, there's still something here. You still need to put a 0 here if you didn't have any z's. Okay, now that everything looks like it's in order, I don't need to do any algebra to fix the equations. I can just write my matrix as just coefficients. 5, negative 1, 3, negative 2, 3, 5, 7, 92, 2, negative 2, 4, and negative 6. On the TI Inspire, we can come to our calculator and press menu, the number 7, 5, and then we can press menu and the number 7, 1, 1. This will bring up our matrix menu, and we can put in a 3 by 4 matrix. Now we're set up. We can type all of our coefficients directly into the matrix. We have 5, negative 1, 3, negative 2, 3, and then 2, negative 2, 4. Before I hit enter, I'm going to go back and I'm going to check and make sure that my matrix looks good. I've got 5, negative 1, 3, negative 2, 3, 5, 7, 92, 2, negative 2, 4, negative 6. Everything looks good here in my matrix, so I can go ahead and push enter. And there it is. When x is 1, y is 0, z is 0. So 1x equals negative 1, 1y equals 12, 1z equals 5. My ordered triple is negative 1, 12, and 5. And we're going to find that in answer option C. For number 18, they give us, the table shows atomic weights of 3 compounds. We have carbon, hydrogen, and oxygen. And what is the atomic weight of carbon? So we don't know the atomic weight of carbon. We know the atomic weight of glucose. It's 180. We know the atomic weight of carbon dioxide. It's 44. And hydrogen peroxide is 34. But this is just a system, and we can use it, solve it using the matrix. For glucose, this is my glucose equation. I'm going to have one of the carbons, 0 of the hydrogens, and 12 of the hydrogens. Whoops. Oh, I was doing carbon dioxide, I think. Okay, so I was able to catch myself early before I went any further. For glucose, we have 6 carbons. We have 12 hydrogens, 6 oxygens, and the total weight of that is 180. For my carbon dioxide, I'm going to have 1 carbon, 0 hydrogen, 2 of the oxygen atoms, and the total atomic weight will be 44. And now for my hydrogen peroxide, I'm going to have 0 carbon, 2 hydrogens, and 2 oxygen atoms. Altogether, that weighs 34. So we're going to put this one into the matrix. We can put in our reduced row echelon form. So we're going to type in menu 75, menu 711. Our matrix menu pops up, and we are looking for 3 rows, and we are looking for 4 columns. I'm ready to go ahead and type in my matrix, and I'm going to just use what I see here. 6, 12, 6, and 180 is my first row. 1, 0, 2, 44 will be my second row. And 0, 2, 2, 34 will be my last row. I'm ready to hit enter, and we can see this come up. My first variable here was carbon, my second variable was hydrogen, my third variable was oxygen, and the last thing that we got was weight. So what this is telling me is that when you have 1 carbon atom, 0 hydrogen, and 0 oxygen atoms, carbon must weigh 12. For hydrogen, it weighs 1, and for oxygen, it weighs 16. So it's asking me, what is the atomic weight of carbon? And we just saw that on here. Carbon weighs 12 on the atomic weight scale. So in my griddable, that's what I would write down. I would write down 12. Okay. So each year, a roofing contractor hires 2 types of employees. We've got temp, and we've got part-time. Temp employees get $650 a week. Part-time employees get $450 a week. So temp is here at $650, and $450 is for part-time. All right. You can hire between 25 and 35 employees, but you can't go below 25, and you can't go above 35 employees. Also, you can't spend more than $22,000 every week. So let's figure out a couple of the statements here. The contractor can hire 35 temporary employees. Temporary employees cost $650 a week. So if I have 35 employees and I pay them $650 a piece, then the total of that is $22,750. Now, unfortunately, my budget is $22,000. So $22,000 is over that budget. I know for a fact that F isn't true. I could stop here. A good test-taking strategy, of course. Which statement is not true? This one is not true, so we can be done. F is the right answer here. If you wanted to make sure, though, double sure, you go back and you say the contractor can hire 32 part-time employees. All right. Well, part-time employees work $450 a week. So 32 times 450 plus, and then you want to hire 3 temporary employees. So 3 temporary employees will cost you $650 per week. Okay. When you multiply and then add these 2 part-time and temporary employees together, this is about $16,000, $16,350. That's well within this $22,000 budget, so this is definitely true. You can do that. If you hire both types of employees, the contractor will minimize their cost at $11,000. Okay, so the cheapest type of labor here will be part-time. Part-timers make $450 a week, and I have to hire both types of them. So I have to have at least 25 employees, so I'm going to say that I'm going to hire 24 employees that are part-time because I only have to pay them $450 a week. And then I'm going to hire on 1 of my temporary employees because I have to pay them a bigger fee of $650. All right, so 24 times 450, and then 1 times 650 gives me $11,450. And yes, that's true. That's what we see here, $11,450. So this is true. All the above is not applicable here. The only statement that is not true is F. The contractor can hire 35 employees. That is not true. they would have to hire not 35, they couldn't even hire 34 because they're $650 a piece for a temporary employee. So you wouldn't be able to hire 34, you'd have to hire 33 to still meet your $22,000 budget. On number 20, they are asking us to write the equation of these inequality lines and then figure out which set matches. I always start top down. You can start wherever you want to get in. So I'm going to get your answer. So I'm going to take my slope first. With this straight line, we know that it's y equals mx plus b. And we know that my slope here, this m, is what I'm looking for. So I'm going to do rise over run. This goes up 2 units and over 4 units. So rise was 2 and over run was 4. It's 1/2. So y equals 1/2 x. And then my y-intercept is right here at 3. That's where my line crosses the y-axis, at 3. I look over here and I don't see any of my equations in this form. They're all in standard form. So I'm going to need to convert. The one thing I can immediately see is that none of my x's have a fraction. They are all 1s. So I'm going to have to get rid of this 1/2. To do that, I just need to multiply everything by 2. So 2 times 3 is 6. 2 times 1/2. In other words, what's 1/2 of 2, which is 1. So we're just left with x. 2 times y is 2 of those y's. I look back over here, and I'm seeing that all of my x's and y's are on one side, and all of my numbers are on the other side. So I'm going to put all of my x's and y's on the left side, and I'm going to keep 6 over here. Subtracting x on both sides gives me 2y minus x equals 6. Now we need to make some decisions about our inequality symbol. Right now I have an equal sign, and it needs to be an inequality because we have shading here. I look at my line, and I go right to my y-intercept here, this positive 3. And I can see that I'm shading numbers like 2 and 1 and 0. And all of those numbers are actually less than 3. So I'm going to use my less than symbol here. And I notice also that this is a solid line. It's not a dashed line, it's a solid line. So I'm going to say it is less than or equal to 6. 2y minus x is less than or equal to 6 matches up with this equation right here. And no other equations. All these other equations have other stuff going on. Let's just make sure that now we think we have a lead. Let's just make sure that this is the right one. This says x is less than or equal to 2. So I go where x is 2 on the axis right here. And are we shading numbers that are smaller than 2? A number smaller than 2 would be like 1, 0, and all that stuff. And we can see it shaded, so that's good. This over here says x is bigger than negative 2. So I go on my x-axis again. Here's negative 2. I'm shading numbers that are bigger than negative 2. So maybe positive 2, maybe positive 1. Those are all bigger. And I can see, yeah, that's where they shaded in. So this one works. So we can see that A is going to be our answer here for this page.